welcome everybody to Scicloj. Scicloj is a community that discusses science, data science, machine learning tools and techniques. I'm Sami Kallinen. I'll be moderating this session today and try to help things run as smooth as possible. And it's good that everybody knows and are aware that these meetings will be on YouTube in the future, and so you can go back and look at them, but also just to be aware that this is not a private session. Just one word about myself. I have a company here in Helsinki called 8-Bit Chip. We work a lot with data applications of different sorts, B2C type of services. But the main point of today is that we have Konrad here, Konrad Kühne. He's from Heidelberg, Germany, and is a CEO and data engineer at Lambda Forge, a consultancy that specializes in information system engineering. But today he's here. I'm happy to have him here. I had the chance to meet him in Scicloj a couple of weeks ago. Very nice guy and super curious about this presentation. Konrad is going to talk about Datahike and Datalog in general. As if I understood correctly, Konrad is going to first talk a little bit about the background and then jump into live coding and see how things actually work. Like usually before we start, we like to also make a note that we really hope for active discussions with lots of questions. I know it's not maybe the easiest format to do it, but be brave and jump in. That's how we get more value out of this. You can ask whenever you want in the middle of the presentation. You can also, if you don't have a microphone or feel a bit shy, you can put questions in the chat, and I try to monitor that and ask Konrad if there's anything through that channel. But really be brave and discuss directly. We have a lot of time. It's not a formal gathering. It's meant to be a discussion. And then also we like to just note that if you're not too shy, we would encourage to keep your camera on while listening. It's nicer for the presenter to get the sense of the people in the other end. And also, like normal sort of how this works, it's good if you put your microphone on mute while you're listening. So background noises, dogs barking, family going about their lives, or offices, depending on what part of the world you are currently. So those noises don't come into the stream. So please go on mute. But of course, feel free also to jump in with questions like us. And after, if we have time, we probably would like to have a discussion about the community challenges, issues within the community after Konrad's presentation. We have about 2 hours, so I won't say the exact times because it will be different in all. Depending where you are, but in about 2 hours we will usually stop. Yeah, okay, enough about the general things. I'm super stoked and happy to invite Konrad, and please, the mic is yours.
All right, thank you, Sami, for the introduction. All right, I will share first my screen. All right, so basically I did a similar talk a couple of weeks ago in Stockholm, just before the closure trip. So some of the slides will be the same, but I cut it a little bit, and the live coding will be different. For in the first part, I will just have a small presentation So I will talk why I'm doing this, why I use Datalog, how we came to build Datahike, and then I will do some live coding. I was at a hackathon in Helsinki after the closure trip, and I got a pretty nice data set there, and I thought I could just play a little bit with it afterwards. All right. So why should I use Datalog and not just SQL or something else? The thing is, the Datomic concept was or is well established. So I myself did some successful applications in customer projects. Datalog itself is pretty popular in academic research. So my co-founder Christian, he's a researcher. He's doing his PhD in Canada right now, and he's pretty well known, or he's interested in programming language research, and their Datalog is used widely. So they are using it, for instance, for static code analysis. So it's not a dead language. But the problem right now is in the closure world, we have only few implementations of Datalog and only few open source solutions. Yeah. So where is Datalog used? It is used in triple stores. So we have stores that have three-part segments, which are entity, attribute, and value. And these segments are stored in the database and then queried with Datalog. And each element can be either, or each value can be either a primitive data type, like integer or long or string, or it could be a reference to another data segment. And the most famous database in the closure world is, of course, Datomic, which made it popular. So it's a transactional immutable distributed database with commercial licensing. So you're paying for a license per year, and then you can use it. So it is a database of facts. So you only append new facts in there. It is developed by Schicloj, and it was the motivation for closure. In the core, it has several interdependent components. So it has a separate client, server, storage. It has a transactor, and it has a console. And it implements a flavor of Datalog with a certain syntax. And since Datomic doesn't or isn't interested in a specific storage, you can have, it has many persistent protocols, so you can store it either in the cloud or in relational database, or so there are many things there. On the other hand, a couple of years ago, an open source variant was created. Datascript it is a cross-platform in-memory implementation. It has a very fast in-memory engine. It supports a large part of the Datalog used in Datomic and also a large part of the API. But it doesn't have storage capabilities, and it only uses a very loose data validation. So now Datalog, how does it look like? Or first, what is it? It's a declarative logic programming language. It's a subset of Prolog. For you who heard of that, it uses first order logic. It is not Turing complete, so it definitely terminates. And it's in the end, it's just a list of predicates you're defining, and it tries to join all together, and then you get the data. So how does it look like? It looks like this. So you have on the left side you have a SQL query. Select ID from members where name is Alice. So we want to find the ID of Alice. In Scicloj it looks like that. And Prolog, it's just one line. And in Datalog you have this vector syntax where you have find and then the variable you're looking for, and then the clause you want to have. So the ID, we want to find the ID where we have the attribute name and the value Alice, and yeah, this finds you your data. And I will show you some simple queries you can use in there. But first I will define the facts that are stored in our database. So we have 3 entities. So each entity has a name and an age. So the first entity is Alice, a name and Alice, and she has the age 45, and also for the other guys. And now we query that. So here we have just a simple query that just finds a specific variable. We can make unions. So let's find all the people that have a certain age. We can also find anything. That's also possible. And also you can have inputs in there. So you can say, okay, find the age for a certain input. In this case, we have the input Alice. And then we have just the unification over the name and the age. And then we find the value we want to have. All right. And also you can define what results you want to have. So if you want to have just the first result, you can just add the dot in there, and then you get just one result. You can also have just a vector if you like that, or you can have tuples. The next interesting syntax is the pulse syntax in there. So this is used to select certain information from your entity. For instance, if we have name, age, and a car in our data, we can say, okay, either give us everything or give us the name or the age, or if the car is a reference, give us everything that the reference has, and so on and so forth. And you can embed that within your queries. So you can say, okay, first give me all entities we have, and then just give me the name and the age. All right, and that's it for Datalog. Are there questions so far? Can't see the chat. Okay. So Datahike itself came alive roughly 2 years ago. Before that, we tried to build another database, a distributed database, which should replicate just data with certain data types, but that wasn't very feasible. And then we came across DataScript, and also we saw the talk about the hitchhiker tree. And we said, okay, let's see if we can combine that, because we created a storage layer for the hitchhiker tree index, and DataScript itself didn't have a storage layer, so we tried to combine that. So we could have a Datalog engine or a Datalog database that can be stored and queried. And yeah, we started 2 years ago with that. And over the years, last year we didn't do that much, but this year with the support from the Swedish government, we could improve it. So we added schema capabilities and time travel, and we could clean it really up to make it production ready. And within the whole development process, we thought about, okay, what should it be in the future? What should be the philosophy behind that? And okay, we said, okay, it should be open source, because open source is awesome. it should have a Datalog query engine, and which should be so both Datahike and the Datalog engine should be extensible, so you can create or you can extend it like your business needs it to. Then the whole system should be composable and of course extensible. So if you say, okay, I want to have a full text index in there, I can plug it in somewhere. And of course it should be configurable. So there are many ways to use it. And all right, so what are the features right now? We have a Datalog query engine, which is similar to what Datahike is using. We have several indices that are used to query the data. We have different schema flexibility, so we can have a schema either on write or on read. We have different storage solutions in place right now. So either in memory or file or ReloDB or Postgres. So these things are right now defined via protocol, so you can extend it if you like. So some people already wrote a layer for S3, so this is pretty easy. Also, Datahike is right now auditable, so you have time travel and a history of all facts that were added or removed. And of course, with GDPR compliancy, we are also able to remove data completely. And we want to be community friendly, so we want it to be modular and with many extensible components. All right. So let's have a short look under the hood. So what are the internals? When I started, it was like magic because I didn't know the code base, and it was not that easy for me because at that time I didn't do that much of Clojure, but for customers other stuff. So I dig into that and I pulled some things apart. And now it looks like that. So we have a simple API level with the connection from where the connection from the application happens. We have a connector component which handles all mutable DB connections and also the persistence communication. So there are the protocols for all your storage layers. And of course, we have the query engine, which has a Datalog parser, which is also now a separate library, which joins the predicates from in the query, and which uses just the database search capabilities. And the database itself is just a Clojure record, which has the different indices in it and some functions to search it, to store it, and so on. And on the other hand, we have different indices. So basically, as I said, we have a triple store and everything is stored as entity attribute value. And we have different indices for which are differently sorted. So the first is the EAV and the T is for transaction. EAV is sorted like entity, first entity, then attribute, then value. The AEVT is sorted like attribute and then entity and then value. And the last one is attribute value entity. This is for different queries and for different schema. And also we have some temporal indices just for the storage of historical data. And finally, we have the store with the persistent. So there is it could be Postgres or just an item in memory. Okay. Now I will show you a little bit how the transaction really works. So if you transact new data in there, like this map, so we have the name Alice and the age 42, and you just transact this vector, basically what happens internally is it is split into the two datums because we have two different attributes, and then it is stored as these quadruple into the store, and vice versa. We have the query flow. So if you say, okay, find the entity ID and the attribute where the name is Alice and we want to have the age, then the query engine also splits this up, and we have two searches internally. So the first one is just looking for the name with Alice, and the second one is pulling every age in there, and the query engine combines that. So we get the name and we get the age, and the query engine just joins it. All right, I think I was a little bit fast, I guess, but I think that's okay, because now I think I will start with the live coding. And I was as I said, I was at the hackathon in Helsinki, where we built some stuff with the public transportation system, and we had access to that, and it's also open data, so we cleaned the data and we interacted with it. And for this or for my example, I just took one of the data and cleaned it for me to work with, and there I will show you how Datahike or Datalog works. But before that, are there any questions? All right. Yes, the slides will be available. So I will also the code will be available. I will add that by the end of the meeting. All right. Okay, let's see. So you can I think it's all right. So basically, we can ignore the first part of the code, which is just helper functions to work with the data. And here is just the example for the data from Helsinki. So in there are just data from let me show you, from the Helsinki open data. So this is just data from open data from the city, like parks or museums and stuff like that. And yeah, and I used just I used a subset from that. And okay, let's have a look at how the data looks like right now. So you can just ignore the first parts here. They are just for the geodata in there. So basically, we have just a few attributes we want to use in there. Just the name of the location, the category, like is it healthcare, is it safety, it's a daycare, and so on and so forth. And also some location data, and of course its name. And I just cleaned all that up because always data is a little bit messy and there were duplicates, and yeah, and I did that all beforehand. So right now we have some, let's see, some 1,800 data points in there, and let's just try to work with that. So basically, what I did is I just played a little bit around the last days and just thought about, okay, let's do that. Let's do that together. And on the way, I will show you how to interact with it using using Datalog. So here we are. So here's the data, and for Datahike itself, we need as a configuration, we can just use an URI. In this case, I said, okay, I'm using as storage the local file system, and in the file system, just in the temp folder. And here I just create a new database, so it's completely empty without a schema, and I can just connect to that, and I will try to transact the new data I have. So basically, I will just show you how the first entry of the data looks like. So it looks like something like that. Just a category, which is a keyword, latitude or longitude as floats. A name is a string in Finnish and in English, and a geohash for search later on. Okay. So if I try to just transact this data, of course we have per default schema on write approach, which means that the data is validated on transaction. And since we don't have a schema defined yet, yeah, we got an exception. So first we have to do that. Let's see what we do. It's the name. So basically, that's the way I'm starting to work with new data. I will just say, okay, how does the data look like, and what type does it have, and so on and so forth. So for Datahike, we need to define for each attribute three things. For once, we need an identifier. What's the name of that attribute? We need let me see. We need a value type. So is it a string? Is it a double, or is it a date? And we need the cardinality. So whether we can have one or more entities of that attribute, of that value. And yeah, let's see how the data looks like. We have name, we have latitude, longitude, and yeah, okay. Let's copy that, and let's see how this works. So if there are any questions within within this presentation, just ask me, and I will just move along here. So we need name, we need the category, and this is another value type. So this is of type keyword, and this is wrong, and this is of course also cardinality, also of 1, and we have 2 times latitude and longitude. So this is a double. All right. This is a latitude, longitude, and what else is missing? The geohash. I will come to that later once we work with that. Then I will explain what the geohash is about. And latitude, longitude, name. Okay. And okay. Okay. Let's see how this works. Yeah. Okay, this works. And now we can say, okay, let's transact all the data we have in there. So let's so let's see how many we have. I think 2000 or something like that. Yeah. Oh, let's split that up. Let's partition that and partition and the data, and let's transact it every 1,000 entries. So we do that like that, and then we just need, I think, the transaction, and then it takes some seconds because it's not optimized for speed at the moment. So we are working on that. I can, but in the meantime, I can start maybe with the first query. So let's see what we can do. So now the data is in there, and let's have a look what's how this looks like. So let's first see just how many elements we have in there. So let's see. So this looks like that. So the Q is for query, and then you just define the Datalog query, and then of course you have to use the database at that point in time, which is done via the deref on the connection. And here we can see, okay, we have the real amount for that. But let's see, okay, we have different categories. So let's see how many categories we have in here. Let's see, category. Oh, that's wrong. That's wrong. We want to see the categories, so we have to count the category. So we have 7 categories in there. All right, what else can we do? We can let's see how the distribution of the categories, for instance. So let's see, okay, let's get all the categories out there. That's wrong. So we have to do it like that. All right. So but we got only these few because the return of the query is always set. So we don't have duplicates. That's why I have to add the entity ID here, so we get each entry. So now we have a list of all the categories of all entries in its category, and let's just work with that data and say, okay, category, and then frequencies, and we can see, okay, how many different categories are there in our database. Oh, that's I did it wrong. Second, and then frequencies. And we can see, okay, the most part is daycare, because in the hackathon we selected the data that way. We have some culture, some environment, which are like gardens or something like that. We have educations for schools and universities, health for doctors and so on, and safety for, I don't know what that was, and traffic, which are just terminals and or bus terminals and stuff like that. And yeah, so this is how you can get very simple data from that. But we can do more. Let's see. Maybe we can see. Yeah, let's use the geohash I created in there. So basically, what the geohash is, it creates in a certain area one hash for all the latitude and longitude which is in there, and I'm using that to find the surroundings of my point in a map. So if we have a look at this map, for instance, what this means is, so the geohash divides the map into just different areas, and each area has the same hash value. And then you can say, okay, if every entry in this area has the same hash value, so this is nearby, and you can use that to find things in your database. And yeah, I did that here. So that's what I did with all these functions up here. And as a first point, I just copied the data from the Helsinki train station in here, and wanted to work with that. So this is just latitude and longitude, and here I wanted to see, okay, what hashes are nearby. So this gives me a certain amount of hashes. So if we look at that, okay, these are the hashes that are nearby, and we can query that and see what's in there. And let's do that. So let's say, okay, find me all entities with that are nearby. So let's say, okay, we want to have all the names from the nearest area. Then we can just say, okay, we have as input, we have the database itself, and a geohash that's from the nearby from the nearby area. Let's call it G, and then we say, okay, we have the connection, and let's have it as a list. Static list nearby geohashes. That's wrong. Yeah, near train station, that's it. Yeah, that's a list. So we can also, as input, we can have singular values like this one, but also we can have a whole list which can be used to join values. And in this case, let's see what we can find here. Okay, we can find some. Okay, I should use the English name probably. Since I don't speak Finnish. Okay, we have a botanic garden nearby. We have museums. We have, all right. Let's filter the data a little bit. Let's say we only care for a certain, so we can just add another value in there. Let's say, okay, we want to search only for a certain category, and then we just edit it there. So we say, okay, now I want to find all nearby healthcare facilities, and oh, okay, there are none. Let's see education. Let's see whether there's there's a there. And this is pretty nice to work like that in data. All right, what else can we do? Any questions? Yes, right now Datahike is just a simple library. So you just import it in the project and use it, but we are planning to have a separate client and server model. So you can have a transactor and a query engine, and yeah, that's the plan right now. Yeah, so that's what we are working on. Okay. Yeah. So now I will show you a little bit the pull syntax I mentioned before. So you can select any data you like. So you can just say pull, and we want to have maybe everything that this entity has. And you can see, okay, the ID, the category, the GeoHash, the location, and so on and so forth. And that's basically yeah, that's basically how you do it. You can also just use the basic pull syntax for that. So let's see how we can do that. Let's see how this looks like. Let's see, because I created all the data with an index in of the name, I can just pull specific data out of it using just the name and the data itself. And let's see, it looks something like that. And here we can also say, okay, give me just any data from that. Oh, I didn't specify it as unique. I will do that now. Let's see. Where is it? Name. Let's do that. The transact. So you can update your schema as you like. You can say, okay, let's have it. Name should be unique. Let's do it differently. Let's since we have to create the new index, it doesn't do it right now in the background when you just change the schema. Let's create the database from new. Just to do that, so that's the easiest way right now. But we have to to do that, or to be able to do that in the future. So now I will just add this unique identifier for the name, so we can index that by value in the future. So let's do that again. Let's transact all the data again, and then we can pull the data just using its name, for instance. All right, now it's possible. Okay, so you can see here the botanic garden. We can just reference it by its name, and not just by some ID. So if we want to have it like an ID or directly, we can also do that, something like that. This is also possible if you if this data doesn't have a unique index. All right. Let's see what else we can do. Let's see. Okay, let's try to just let's say, okay, we have data that needs to be removed. How could we do that? In the base case is just to retract it from the current index. So what we do is, let's say we just remove one of these entries in here. Let's say we have to remove this square. How could we do that? Simply by calling the retract entity function in Datalog, and just say, okay, we just remove this entity with this ID, and then it's gone. So let's see before and after. Let's see. So and connection. Yeah. It's still there in the current view. It's still there, and let's retract this entity. Okay. Now, if we try to pull it, yeah, so it's not found in the current index anymore. So the entity is gone. Let's see if we could find it in the history. So since the last release, we have a history which can be queried. The pull syntax isn't working there, but but you can use the default query syntax for that. So let's find it. Let's find the entity with the name with this name in the history database, and you query the history just like that. You call history on the current connection. They're on the current database, and let's see. Yeah, there it is. And let's see if all data is still in there. And yeah, in the history you can find it, and let's see how this looks like if we just query that in the normal in the current database. Yeah, and it's gone. So now we have time travel, and you can also query that at a certain point in time if you like. Let's say we have the current date, which is just a Java util date. Okay. Let's retract something else. Let's say, this park. Let's see. Let's remove that. And let's see. Okay, it should be gone. So let's see. In the history it should be, in the current database it should be gone. Yes. In the history you would find it, but you can also see you would see the whole history of everything. So you would see a current entry and also the past. But if you like to see the database at a certain point in time, you use the as of database with the date you want to see it, and here you maybe I did a mistake somewhere. Oh, it's gone. Maybe I have a bug in there. As of. Let's see whether it's in the history. There it should be. No. That's weird. Maybe I've written it wrong. Yeah, this is still in there.
Theodore
right.
at the chat is asking if you removed it by the English name. Park doesn't sound Finnish.
Yes, I did it. Thank you. Thanks. So let's see again. We need, of course, we need the Finnish name. And that's it. So we need the park. That's the Finnish name. Yes. All right. Okay. All right. Then this should be in. It's again the wrong name. Here I should copy that one, and now it should work. Yeah, it's in the history, and now let's see as of and the as of date. Yeah, here it still is. Okay, cool. No bugs so far. Okay, what else can we do? This is that. Let's see. Let's add. You can let's see how reference would work. So let's transact something like, okay, let's have an entity that's a visit at a certain date, and let's add it as a reference. Let's add one of the location we found nearby, and and then we can see how the, for instance, this the nested put syntax would work like. So how references in queries would work to other entities. So it would look like that. So let's have it like something like db.type instant. So at the moment we only support a subset of the schema of Datomic. So missing are right now tuples and some byte stuff. But internally, you should be able in the future to define any closure spec you like to, and define just new shapes of your data. This is also something we are working on right now. This is not finished yet, and yeah, this should make the schema a little bit more flexible. Yeah, let's have a note in there. It should be a string. Yeah, it's always the same. Yeah, let's have many nodes in there. Yeah, that's okay. And let's see how the many reference looks like. And then we have, of course, the location. So this is here's a typo. Value type db.type, and this is a reference. So here we will reference each location we have in there, and cardinality, and this would be also one. So we have, for each location we have one wizard, or the other way around, one wizard for every location. Okay, and yeah, that's it, I guess. Okay, let's find again some nearby stuff. Let's see. What do we want to? Let's go to the botanic garden. Let's visit that, and let's see how I can do that. So we have the visit date, which should be just Java date, and we have the visit node, which could be anything, a list of things, and we have the location, which should be the name of the location, and yeah, and beautiful, with a spelling error, so we can fix that later. Okay, now it's in the database. Let's see. Let's find our data again. Where and visit. Let's see. Let's pull everything we have in there, and okay. So I will So here you can see, okay, we have for once we have a list of nodes in there, and also we have the location as a reference, and you can see here the reference is a DB ID, and with the standard pull you only get the reference. And if you want to have the data behind the reference, you just say, okay, visit location, and there you can have again the pull syntax you want to have, or the pull syntax for what you want to have, and in this time we get the nested data. So we have the data location again, and here in the location we get all the data from the location. So the key geohash, latitude, the name, and so on. And okay, let's see what we can do. Let's say we want to add another node in there. How would you do that? The ID. So this time I don't have a unique entity, so I have to dereference the this data by the database ID. So in this case 1814. So let's transact to the connection something like visit database ID 1814, visit another node, maybe, yeah, nice, and oh, I see, I did something wrong. Should be a hash map, DB ID, the attribute I want to change, or I want to add. All right. Okay, let's see. Yeah, and then we have both nodes in here. All right, nice. What else can we do? Okay. We can say, okay, let's delete data completely. Let's say, okay, the GDPR has to be fulfilled, and people want to retract their data completely. Okay, let's see how this would work. So let's see again. Let's see what environment we can remove completely. Yeah, let's remove this here completely from the index. I will just do it here above, so we can just query here again the as of data and so on. Yeah, let's do it. Let's do that here. Let's see. Okay. I will clean that up later on after that, and let's see. Okay, let's transact, and then you have the purge function, which purges a complete entity. From the index, of course, the queries afterwards wouldn't work anymore. So I will do that here. So let's transact that. Okay. So now if we go up and have a look at the environment, yeah, obviously it's gone. And also let's copy that down here and find and try to find this name in the history, and it's also gone. So the data is completely removed from the history and from the current view, and yeah, and your GDPR officer would be happy. Yeah, and I think what's the time? Yeah, I think. Are there any more questions? What do you want to see? What I would do with the data? Because that's right now what I wanted to show you.
There's a question in the chat by Martin Varela, and he's asking how Datahike compares to Crux.
All right, it's similar. Crux itself, I talked with the guys at the Closure Tree conference. Crux is also composable in open source, and it has a Datalog engine to query the data, but it stores its data in without a schema in a document store. So it's a document store and not a triple store like us. It also has an index in there for the search, but it's not a triple store. Yeah, and also we're trying to work with them, so to have some libraries that would work on both on Datahike and Crux. So, for instance, working with the Datalog engine, or how to manipulate the Datalog queries. Any more questions?
Konrad?
Yes.
Hi, hello. Could you tell a little about the situation in ClojureScript? I mean, there is the DataScript project, and what is the situation of Datahike in relation to that? Yeah, thanks.
Yeah, ClojureScript, up until the last release, ClojureScript was supported, but also with update from some libraries we are using, this support isn't anymore. So we can't build ClojureScript right now, and we have to fix that. So, but it's right now we have an internal discussion whether we want to support ClojureScript or not. Because we're moving Datahike to server and not to the browser. So and then it's the question, why should I use Node.js in the backend for Datahike if we have the JVM? Because if we want to support JavaScript, we have to port all the primitives for multi-threading from the JVM to the JavaScript world, and this is a little bit painful. Yeah.
Yeah, thanks.
Any more questions?
Yeah. Hi, can you hear me?
Hi. Yes.
Oh, hi. Yeah, so my question is actually an apology, because I opened an issue on Conserve, the Conserve website, just before the meetup, because I was looking at the code. I was wondering how Conserve was creating a store backed by the hitchhiker tree, and I realized that it's something that is not exposed in the API of Conserve from a user perspective. So if you look at the Conserve README, you will see how to create file stores in-memory, file-based, and external, but you don't have any mention of how to have a hitchhiker tree backend. So I opened an issue in the hope that maybe it's possible to specify at the Conserve level that you want to store backed by the hitchhiker tree. Does that make any sense to you?
So basically, I didn't write Conserve because at that point Christian, so my co-founder, was involved in that. So basically, for me it would make sense, and yeah, if there's an open issue, I think Christian will be able to answer that better than me. Because I didn't, I only wrote a small part of conserver, and I wasn't that involved in that.
Maybe Danielle and Konrad, maybe it is a good idea to tell a little bit about what conserve is and how it relates to.
Okay.
Yeah. So.
Okay. Conserver is just a protocol for a key value store. So we can store any key values like we would do in a hash map, for instance. And underneath, we have a protocol for different storage layers. So for file system, for Postgres, for Redis, and so on.
So I wrote a layer on top of conserve, which is called, it's released also in open source. It's called Campbell, and it does the schema on write thing of Datahike.
Ah, perfect. That's
only
that's
that.
Nice. That's
yeah.
Yeah, that's nice. Yeah. Because at some points, for instance, I don't want to use only key value stores. If you have sessions or something like that, I don't want a full-blown database, but only conserve. So, yeah.
Yeah.
Ah, cool. Yeah, send me the link. I want to have a look at that.
Okay, sure.
There's another question in the chat from Theodore. You choose to work from a file during the live coding. Do you have a rule of thumb using files as opposed to moving to a store like Postgres? How far can you get with a file?
I haven't. Yeah, I have some projects to measure the performance right now. I haven't evaluated it completely right now, so I'm not really sure where the point is to move from file to Postgres. I haven't measured that yet. But I started writing a blog post about that with the numbers, with the first numbers, and there you can see how the different storage layer behaves on different load, and also the different indices, because you can, so basically we have the hitchhiker tree as an index, and also the persistent sorted set from Datascript. And also, I compared how they behave on different with different sizes.
I have another question?
Yeah, of course.
I was wondering about the separation of the Datalog parser. So that was actually very smart thing to do, because the query language should not be hard linked with the implementation. So the question I have is yeah. So the question is the only thing is this the maximum abstraction? Is it abstracted away in the most how do you say, in the maximal way, or is it possible to beyond the parser, maybe there is some logic that can be abstracted away from the underlying implementation, or not? Like, is this the best we can do? Is just to abstract away the parser, or can we do more and abstract it one level deeper or something like that? I don't know. Just a question.
Yeah, that's a good question. I'm not really sure. But basically, I didn't. So the parser itself, it's from Datascript. How Datascript did that in the past, and we did that to be able to also compile from these abstract data structures which represent the Datalog, syntax, and we want to compile that from these structures back to Datalog again. So basically, we want to insert some optimizations in there to make the query faster. This was the intent for restructuring, or for making that in a separate library. But I'm not sure how to abstract that even more.
Is it doing? Is the fact that it's a triple store important to a Datalog query engine, or can a Datalog query engine work also on top of other types of stores?
No, it's better for the so it's basically for the triple store, because if you look at the data, they are just triples, and we are just matching to the triples in Datalog. So if you have a look, so the data looks something like, I don't know. Let's have just a look in here. The data just matches for the triple entries in the database. Of course, there are also it's not just triple. There's also transaction, and in Datomic there's some added entities. So you're storing five entries in there, but the Datalog just matches for that. So what internally happens is we just iterate over our whole database based on the index, and see where the matching for each subquery. Let's see. Here's a longer query. Can you? Yeah, here. So the query engine matches for these triple of the data. That's what happens internally. Having that for more than a triple store, it depends on it depends how the structure internally is. Yes, you could extend that for the parser. For the query engine, yeah, this needs to be based on the database. Yeah.
Sure. Thank you.
Yeah.
Maybe you'll find a way to abstract one level deeper in tomorrow or next week or in a month or something like that. Maybe, I don't know.
Yeah, we will work on the query engine. We will work because we want to have a query planner in there at some point.
Yeah.
So basically, you can write inefficient queries in there. So let's say you can, if we have such a query, you can write it in a way where you join pretty late, or where you filter data pretty late, and this can be optimized. So you can see, once you have statistics from the data, you can see, okay, if you join over data or a small data set early on, it's better. So you can write a planner for that.
Ah, nice. So there is a query planner in the works.
It's planned. It's not. We are not working on right now because we have to work on the client server.
The query planner is planned. That's perfect.
It's the query planner is planned. Yes.
It's fantastic. Okay, great.
Konrad, maybe
Yes.
Would you like to tell a little bit about applications, about how Datahike is currently being used or going to be used in actual project?
Yeah, so right now it will be in production soon. So right now it's used by the Swedish government for the public employment service. They're using it for dev and test environments, and they are planning to, or they planned to use it in production soon. And for sizes, I think a couple of millions entries would be feasible, but if you want to have really large data, then of course we can't compete with Datomic, because we don't have the scale yet. and it's not optimized for really large scale applications right now. So I will say, okay, small to medium sized application, that's where it's possible. And of course, we are using it internally in our company right now for some ERP system.
Any more questions or comments? What did you find interesting? What were you inspired by?
Yeah, so if that is okay, then maybe I could ask Konrad, since you are using it at your company, do you feel that you need some layer above Datalog in your users? And I'm asking it also because Daniel earlier told us that he has built a certain layer above database, kind of an ORM maybe. And do you feel that anything is necessary as another layer used together with Datalog in general?
Right now, I'm pretty happy with just Datalog. So I'm not really a big fan of ORM layers, because you have to write so many things again and again. And if the query or even the pull syntax is enough, then that's really fine. So and if you want to have more features like for instance the geohash stuff I added here, you can add that to Datalog itself. So you can have in the future, if it's not there yet, but you could have, let's say you can have a function in here that finds a nearby data, for instance. So this is possible.
I think I can say something to Daniel regarding to his question, and that is that the layer that I wrote on top of conserve is actually existing in Datahike today, because it's the schema on write functionality. Of course, when I wrote Campbell, there was no Datahike. It was I wrote this like 3 years ago, I think, something like, or 2 years ago.
Okay.
So there was only some. I had conserve to work with, and there I needed this layer. But Datahike actually is a production ready system. It has many more features than Campbell. Campbell is a very small thing that only does this schema on write thing, and it's like a one person's project for my needs. I wouldn't. So Datahike is very nice. It's a complete system. It has many features actually. Yeah. So yeah, I mean, it's great that we have these options, because when Cognitect announced the Atomic, they made an excellent campaign around it, and people really wanted it. Of course, it was closed source, and it was for pay, and it was a bit difficult for some people and in some contexts. So now we have more options, and it looks like it's only expanding, because this is 2 new databases in 1 year, and with Crux and Datahike.
Yeah.
So we have a lot of toys to play with.
Yeah. And we want to have this modularity between the databases. So I talked with Håkan after his talk about that. Also how the indices behind that works, because they wanted to use, or they wanted to try also the hitchhiker tree in Crux for the index.
Yeah.
And So basically, we want to define some specifications how to work together. So that's what I would like to see in the closure Datalog world.
Yeah, I think the more we can abstract away Datalog, the better it is. It should eventually be abstracted so that you can plug it in any kind of underlying implementation. That would be really neat, and maybe even the same kind of thing, Datalog for the maximum number of things we can put it on. That would be awesome. I think there is many use cases for Datalog. Also, the interesting thing is like it's not really specified, right? There is no spec for Datalog, right?
No, that's what we wanted to talk about. So how to spec how Datalog looks like, because right now we're having the atomic Datalog as a reference, but also this could change any year maybe. I don't know what Cognitect thinks about that and what to add in there. But having some open specifications how to interact with that, how the syntax looks like, that would be pretty neat. Yes.
There is another question in the chat by Bill Tucker. He's wondering if you have an example of showing the historical changes a business at certain situation, changing names over time, that kind of things.
So the history of changes. Okay, let's yeah, we can do that here. Let's see.
Wait.
Okay, let's change some business names over. Yeah, let's do that. Let's do that. I can show you. Let's see. Let's say let's just get everything and just change. Let's see. Yeah, let's have the bank museum and let's change the latitude just a couple of times. Okay. Let's copy that. And let's say, okay, def as of the, let's say, okay, it's now. Okay, transact. DB ID is the name. And let's say, okay, the latitude is, I don't know, 60.1. Okay, this would be, so something like that. Let's transact again. Something like that. Okay, let's see. Okay, let's see. I will just copy from above. Not that one. Where is it? Where is it? Let's write it from new. Find. Yeah. So it's the latitude we are changing in the name, and where the name. Let's see. Latitude. So if we have a look here, and we don't need that. Yeah, so the latest one is the latest one we added, and if we do that now with history, we should see all values that are in, and if you want to see at what time this changed, you have to find the date of the transaction. So you can say something like this, and then you have the times. Let's see. You have the times when this was transacted. So yeah, first you have this one, then you have this one, and then this one. All right. Okay. Should that answer your question?
Bill, who asked the original question, just said he had to leave for another appointment. But
okay.
Thank you. I think it was very clear. While other people are thinking about questions, let me ask a little bit of a more general question. When we met, I think Danielle was asking sort of a question: what our personal wishes and visions are for the community and the development of things. And if I recall correctly, you said that your personal vision, if it doesn't sound too pompous as a phrase, but at least you were talking about how you would want more people to use and know Datalog. That do I remember correctly that this is what you said at the time? So can you elaborate on that? Why is that something that more people? Why should we know? What's the pitch for Datalog?
I think it's pretty precise or pretty describes precisely what data I want to have, and the query itself is also just data. So if I did a lot of SQL stuff, and it was always horrible to work with that, to combine the queries and to interact with that. And yeah, that's why I want to have Datalog in there. Yeah, it's really just data. It's just lists you're working with, and yeah.
So some sort of elegance. If there's any other people here in the meeting who are Datalog fans or curious, feel free to chime in and come with your thoughts.
I just wanted to. Yeah, can you hear me?
Yeah.
Okay. I think Datalog is a fascinating piece of idea, because it goes back to Prolog, the logic programming paradigm. So that's where the roots of Datalog is, in Prolog and in logic programming. And logic programming itself has its roots in artificial intelligence and goes back to the beginning of the computer research into AI. So there is a tremendous amount of research that has gone into these types of reasoning paradigms. It was much bigger at the time, so it was logic programming was much more important in the 60s than it is today now, for various reasons, historical reasons and all kinds of reasons. But it's still here in this kind of ghost form of Datalog or small language, or like core logic or Canran, mini Canran, and all these technologies. They are completely non-mainstream. They are in the margins of computing, Very few people know about them, but they're all related, and they all are based on a very interesting foundation, namely logic. So it's first order logic, and there is a lot. If like for people who are interested, there are lots of papers that you can read. I would refer to Google for an exact list, because it's unending. But just look into the early days of AI. Look at John McCarthy's work. Look at the books by I think it's called The Little Reasoner for Minnie Cameron, and like a simple logic based programming language. Yeah, I mean, there are many resources, but that's basically why I am interested personally in Datalog, because of this heritage and this legacy, and I'm happy to see that it still lives on in these kind of small things, so like Datalog and CoreLogic and Minicameron and stuff like that. Yeah. I hope this was helpful.
Yeah, you're really right. Yeah.
And so maybe if I can ask a small question. So Konrad, you had some examples showing how you use Datalog for actual analysis of data, which is something that many people like to do with SQL. And I think you also showed some little examples that how extensible it is, how sometimes you actually use functions inside your Datalog. And I wonder where it stops. Where are those places where you feel that you will do your analysis outside or partly outside of Datalog, and where actually you would like to keep extending it to do everything like inside a query?
That's a good question. So basically, I have to see where the end is. So we haven't started yet to use any analysis functions in Datahike itself. So I just extended Datalog by some functions like I don't know, date functions and stuff like that. I haven't reached that yet. So I don't know. I think I think the limits are what the JVM can do. So basically, if you're using Python or R, you have a variety of tools in there that you can use that are not yet that much used in the JVM. So basically, if you want to do some machine learning or stuff like that, then I don't know whether Datalog is the right kind for that.
Yeah. Sorry, Martin here. Could you expand a little bit when you say you added some functions to that Datalog? And I guess this nearby feature or something like that. What exactly do you mean when you added?
So I just extended Datalog itself with. So basically, we have some built-in functions. So if you have stuff like if you have a look, stuff like lesser something like that. These functions are built in Datahike right now. So they were in DataScript. So they had a map. I can just show you the code if you like.
Yeah, yes, please.
So basically. They are just Datahike query. So in the query engine, there's a built-in set of functions, but we want to have a protocol so you can just extend that more and more and just call these functions in Datalog itself. So let me see where we have the built-ins here. Yeah, so here we have some functions that are in Datalog right now. So we have get else, get some function. Of course, the something like missing. So if we want to find missing stuff, and I added lesser and greater functions in there, so you can use that in Datalog. So, and here you have just a big map of functions you can use. So here you can see, okay, equals is the equals functions and so on and so forth. And the lesser function is this lesser function, the bigger function, and the greater function is this one, and so on and so forth. And we want to extend this this hash map of functions. So you can say, okay, I want any functions, any side effect free function in there that's possible.
All right, thanks.
There is Theodore is posting a question at the chat. Can you, Konrad, see it, because it will be maybe a little bit difficult to read out. I'll start in any case. I'm quoting it. We were talking a little about Prolog. In Prolog, you can express a person-ancestor relation by expressing it as a recursive rule involving a person-parent relation. Can this be done with Datalog?
No, I don't think so. No, cannot be done.
Theodore, do you want to continue with? Okay, thanks. Simple answer was the answer now. Yeah. Any other questions, comments, reflections? It's quite a few people still here. We've been going for almost 1 hour and 45 minutes, which is not little. So
a question from my side, was it okay the way how I worked with the data? Because at the last meetup, I had just a full list of expressions, and then I just walked through them. And here I just had just the data and started working. So was that okay, or is it take too much?
I think it's
I
fine.
can start. Yes, go ahead.
Yeah, I was going to say, I think it's better to see it develop rather than just see a kind of block of text and the execution.
Okay.
Okay. I like it. Thanks.
Okay, thanks.
Anyone else want to comment? While we're waiting, yes, I really like the format as well. It's nice to see it happen and involve in front of your eyes, and you can follow well when it happens. So I really like this format a lot as well.
Okay.
So I haven't been doing the shout outs, but there's a lot of people in the chat who are thanking for the presentation and saying that it's interesting. The latest one is Martin Harrigan. Let's wait for a few seconds if somebody wants to chime in with a question or a comment before we.
Yeah.
Yes, Daniel.
I'm not sure if it is a good question, because maybe the answer is too long for the time we have. But Konrad, would you like maybe to tell a little more about the implementation and how the implementation, the data structures are maybe different than other implementations? Is it a good question for this time?
So the thing is, I haven't written that. So the big parts the big parts of Datahike I haven't written. So it's a, as I said, it's a fork of Datascript, and so many things from the Datascript code is still in there. I just pulled it apart and I added stuff, and I had to adjust some things in there. So basically, a lot of the internal data structures are still like in Datascript. So if you look at the database records, they're pretty much the same. I just added some more indices and some more attributes there. And the whole interaction with the query engine, I didn't touch that because the query engine was working, and I hadn't the time this year to go into that. I have an understanding how it works, but I haven't written that much into that. So yeah. Basically, the primary parts we worked on is, as I said, okay, it's the schema stuff, it's the temporal index I worked on, and it's really putting it apart and making as many packages as possible, and having as many abstractions above the different components as possible. And then the other part was, of course, the storage implementation, but it's at that point some guys helped us with the protocols above the stores. So this was just, I haven't written that, it was just a pull request, and then we had the protocols with the 4 functions that are necessary for storing it on different backends. Yeah.
Yeah, and so maybe just one more question.
Sure.
Are there any ways you would like people to help? What would you love to see the community doing about your project?
Yeah, this really nice would be the extension for the schema. So I want to have really just a protocol how to define a schema and how the database interacts with that, and then I would like to see, okay, what data types or what shapes of data could you add in there. And also the other thing is, right now, as I said, we're working on the client server stuff, and right now we're in the design phase, how to do that, how the client is, how the server should look like. But we have right now only some ideas how the communication works between that, and what the best practices would be for that, and how the security works. I think I would like to have some open discussion how to do that at some point.
Konrad, what would be the best way of having that discussion with you? Where can one find you for further discussion?
Yeah, on Zulip, or just a GitHub issue, or in the Slack channel. Just write us, and yeah. And the discussion itself would be, I think I will post our ideas about the client server model on GitHub in a Markdown file, and you can just have a pull request with your own ideas on that, and or your own comments, and then we can discuss that there.
Very good, very good. Any other late questions or comments before we slowly start to wrap the discussion for tonight? Yes, if not, feel free to jump in still if you think of something, but if not, And before we wrap this up, I should announce the next meeting. It's pretty soon. There's going to be a meeting the 28th of October this month, in a couple of weeks. And that time we will have Tommy Reiman from Finland as well. He will talk about Malli, plain data schemas in Clojure and ClojureScript. So please keep an eye on it and join again. It's of course related to the subject matter of this talk, and the gang, Tommy's gang, are doing interesting stuff. So it could be interesting to talk to him as well. So please put that in your agenda, your calendars, and join us again then. But yeah, maybe we could wrap this up. It's many thanks, Konrad. It was super, like I already said, it was super interesting, and I learned a lot. It was nice to listen to the conversations that the whole gang here had. Very nice. Thank you for everyone.